Hello and welcome to today's live stream, all about running Sidero Omni with Talos on top of Ampere hardware. And Ampere hardware is based on ARM processors, the ARM chipset, so that like the architecture of the CPU is different. Does that matter? We'll see, right? We can run it on Raspberry Pis. We had some videos on Raspberry Pis, but like that's the things in my home lab. Those are the things behind me. That's not actual, like, let's run production on this and let's figure out what big iron compute looks like in this environment with ARM CPUs. So I'm going to pull up a bunch of people from the backstage here, and we're going to jump into it and see how this works. So first up, let's pull in Peter. How's it going, Peter?
Great. Thanks for having me, Justin.
Yeah, thanks for joining and giving us access to the ARM hardware. Let's get to Andrew.
We like to say Ampere hardware.
So. Ampere, sorry. And Andre. Okay, so here we go. Now here's the setup for everyone that's watching. Is we reach out to Peter and team at NASA, like, hey, can we try running Talos on some Ampere hardware? Like, we'd love to see how this works, and we'd love to see what that looks like. And all we did on our side is we set up an Omni instance and gave you a Pixie endpoint. And we said, hey, can you boot a machine to this Pixie endpoint? I don't even know what this machine looks like, right? Actually, I wanted to pull that up. Which hardware? Do you know which hardware we have?
I have to be honest. You guys surprised me this morning. I thought it was going to be a Mount Collins platform, but I'd have to confirm with the team in the lab to find out exactly what they put up for us at the last minute.
Okay.
But yeah,
but we don't have any access to it outside of like, here's an endpoint, please boot it. And your team was graceful enough to like go to the lab and set up Pixie and booted it to us. So we have a machine inside of Omni, and let's go ahead and share my screen here. And if I go look at my machines, it came up. Like, I didn't do anything. You booted it, set things up, and here it is. And this is a beast of a machine.
That's not a typo. That's not a bug in the Omni UI. That is 128 cores.
I was going to say, as I was saying earlier, gentlemen, I think, or as I mentioned when we were talking at another time, I was expecting to see double the core count, thinking this was going to be a 2-socket system. So it's probably a 1-socket system with an Ampere Ultramax processor that you're seeing there. So yeah, this isn't your Raspberry Pi. Those are workhorse compute cores, not recycled cell phone parts. You know, we go after the big boys, the Xeons, and you know, that range of compute. So yeah,
and awesome. I mean, yeah, like, what's it? 256 gigs of memory, terabyte NVMe storage, and I see 4 NICs over here that were discovered and set. And we didn't customize this in any way with like specific drivers. This is just defaults Talos on our side.
Yeah, no, and as long as you guys are running modern kernels, it should all, like all our Ampere Ultra platform lines are enabled, and man, they've been enabled for quite some time in the upstream. I think like starting 5.4. Yeah, so you've got fully enabled, any of the kernel pieces that would have been needed have been in there for quite some time. And yeah, from a driver perspective, everything else should be straight up what's in, provided in your Linux, from your Linux kernel as well.
Yeah.
So, Peter, can I ask a quick question?
Absolutely.
Do you know, or can you explain about the ARM trusted platform, or I forget what it's called exactly, but there's like guarantees where if you can.
Oh, so are you talking about like the certification process? So like,
yeah.
So, there's ARM has a, because I know there's trusted platform, and that might be, or there's some security piece that I'm not as familiar with. But if we're talking about just booting servers, right, like ARM servers, right, like, and I'm sure what you're getting at is like confidence that it would boot, and like we saw it, Pixie booted, like things showed up, kind of just worked. A lot of that comes directly out of a certification process that Ampere was involved with ARM. It was driven by ARM, and it's called this. I think it's system ready or server ready. The name.
That's what it is.
The name's changed over time, right? But you can think of what it does is it guarantees, like, and it has certain tierings, right? But it guarantees a specific level of, I guess, expected end user experience, right?
Mm-hmm.
And like Ampere's achieved, I believe, all the highest levels for, I think it's like level 5. Don't quote me on that, but I know they have a virtualization certification as well as bare metal, because our instances are the ARM based instances on Azure, GCE, Oracle. And as well as a lot of European and some of the Chinese cloud providers also have us in their ARM offerings. Because of that, that we have that level of certification. And then from a server perspective, what the server certification typically is around, they test it both with open source firmware. So specifically, I know like our Mount Jade platform was used for a lot of this process. They put EDK2, Tiano Core EDK2, OpenBMC, and then they basically run it through a a specific testing of operating systems and all that stuff, Linux based, of course. So it's all to ensure that the end user of the ARM server, right, platform that was certified is delivers a consistent, I guess, experience to what you would expect from other server platforms, right? And specifically around, like booting Linuxes and, the Linux distributions and those sorts of things. But Ampere was involved with a lot of the original creation of that, because let's be real, we were the, really one of the first, as that process was evolving and that certification was evolving, Ampere was the only, really general server available to the market at the time. So, we definitely added feedback to the process and were involved in part of it. So.
Awesome. Cool. Thank you.
As Aaron pointed out in the chat here, this will probably be the shortest live stream ever. At least the initial installation of getting Talos and a Kubernetes cluster up and running, because we assume this is all just going to work. But we did want to run a couple things on top of it and see if we can show off a couple things that you might need to consider if you have a mixed ARM x86 architecture, especially in a single cluster, and how that's going to work. So I'm going to go ahead and just kick off like creating a cluster so we get that rolling and we can play with it from there. And we're going to go with Ampere. We're going to go with latest Talos, and I'm assuming we'll get the latest Kubernetes here. I actually don't think I've run a 31.30.1.
We're on Kubernetes 130 now. That's crazy. I remember working on 1.7, 1.8.
Yeah.
Wow.
I think my first deploy was 1.3. My first production deploy was 1.3.
Really? You're
yeah,
brave.
It was a long time ago. And so we're just going to go with the one machine right now. It's a control plane node. We don't have any other nodes in the system yet. I am going to boot a couple systems as we go here. So let's create this cluster, and we'll get that defaults, apply a patch to allow workloads to run on a control plane, because that's off by defaults. But we want to allow that in this case because we only have one machine. So that's going to go. And while that's going, actually, I want to give access to some other folks, Sidera folks here on inside of this environment. So Andrew, you're in here already as an admin for getting access to this Omni. I'm going to go ahead and add everyone else. I'm sorry, I'm exposing all of your emails. If you thought they were private before, they're not anymore.
Yeah, right.
And
as long as you're using the work one, it's fine.
Can I add multiple at once? I don't know if I can.
I feel a feature request coming. Maybe while he's doing that, real quick, I have a question for you, Peter.
Absolutely.
What's the difference between the Mount Collins and I think I saw Snow? What was it?
Yeah, so you can think of it like this, right? So Ampere produces the SoC. So we make the chip essentially, and we work on when we build that, we typically work with a reference platform, right? So like a lot of the original Ultra work was done on the Mount Jade platform, right? That Mount Jade's a 2-socket system. The Mount Snow is very similar to a Mount Jade, except it's a 1-socket system. So you can think of it this way, right? Like we create the SoC. and a reference platform, reference firmware, both AMI based and open source based, and then we work with the ODMs and ODXs so that way they can create their own platform. So that's like the Supermicros, the HPs, the WeWins, the ASRock racks, like all those different platforms are created off of that, I guess can utilize those resources that we make available when they produce their own platforms. And like you can think of it like they're going to decide like how many card slots are going to be in the system. Are you building it for disk or for NVMe's or for GPUs, right? Like the configuration of what's I guess the layout of like what's in the physical chassis comes into play. And that's not our design choice. We just make sure that we have the interfaces to and the buses in place to provide the paths for the those types of equipment to be built into and integrated with the system. So yeah, you can think of it that those are the Mount Collins is a platform from one ODM, and I can't remember. It might be Foxconn, but don't quote me on that. I could be wrong.
Got it.
And then similarly, the Mount Snow is a different server model. It could be from a different provider. It could also be from Foxconn. I don't know off the top of my head, but yeah, you can think about it like from that perspective.
Got it. Okay.
Yep.
Great.
Yeah, that's a crazy thing. Like just from a history. So I've been here 5 years, and I've seen us come fruition from only providing infrastructure to big cloud providers. Like when I started, we were only focused on the top 8 minus 1 because Amazon makes Graviton, and now it's like to see it come full circle where you can buy an HP server with an Ampere chip in it, down to you can build your own server, workstation, rig with a ASRock rack, and to see it like evolve through that. And I'm not gonna lie, I come from the early days of virtualization and cloud computing infrastructure when and I've run some decent size continuous integration infrastructure that when I see just the sheer core density and see the physics of how it changes the landscape of your data center, right? Like if you're doing this on-prem, because if you think about it, like the perspective of the future going with an Intel or an AMD is liquid cooling, right? Like, or NVIDIA even, right? Like you have to start thinking about liquid cooling to maintain your real estate. So the reality of the alternative is, okay, I have to change my architecture, right? And by moving to, Ampere-based platforms, you can essentially condense, a lot of the compute in your data center and reclaim that real estate. And most people don't realize, like, one of the things that we can also do is tune the, clock frequency to essentially hit specific thermal envelopes in some cases, right? Like for edge or other use cases. That might have some stringent requirement, like, telco, for example, telco edge. I'm in the Metro Boston area, spent a lot of time in the telco industry. We had a lot of, indiscret brick buildings all over the place that have racks in them, right? Like that, they can't necessarily get out of business, yet we need to find a way to increase the compute capacity of that building without in our case, we can't pull more copper through the wall, right? So, there's a lot of challenges, but to me, that's the most interesting dynamic is just seeing the sheer, compute density. And, full disclosure, I had over 700 servers in the last data center I was in by myself. Okay. And, I had the equivalent core density in less than a rack of servers when I built my about 2019, 2020, when I built a OpenStack deployment here inside of Ampere for a short period of time. So, you know what I mean? It's like, it's unfathomable. And then now, I don't know if you guys heard, we're about to come out with another chip this year that reaches up to I think it's 256 cores. So, in a single socket, that's like crazy. So it's when you get to that level of compute too, it changes the way you think about how you run stuff, because you have to be way more effective at cutting up. So obviously technologies like Kubernetes and that allow you to have a tight-grained application control across those cores. It gives you I guess a great way to utilize all that compute power. Sorry for the long-winded answer, but that's the way.
No, this is perfect. I mean, we got the Kubernetes cluster up and running. Everyone else has admin access. I think by the time everyone had admin access, the Kubernetes cluster was up. It was as expected. Things are just working, and this is wonderful. And now that everyone has admin access, I see Tim's screen in my lower corner already flickering with activity of he's deploying stuff. So I don't know what he's doing over there. I was going to point out that, first of all, thank you, Andre, for telling me that I downloaded the wrong file, because I always do that. So I downloaded the Talos config, which would give me Talos control access to the node, even though this is a private. Again, we don't have access to this. We're not VPN'd into your lab. This isn't a public IP address. We would still be able to get access to that API through Omni. And then I installed or I downloaded the install media for this Omni instance. I'm going to go ahead and boot a couple of these machines behind me so we can add more machines to it, especially in a mixed environment. So we'll get an x86 machine and we'll get another ARM machine in the cluster. Tim, do you want to show whatever you're doing, or?
Right now, I'm not doing anything other than making sure I have a connectivity as well. But I was thinking about going through a Kubernetes install and seeing if we can just bin pack this, very much similar, pulling down the sort of the ARM64 metal ISO, metal image, and just booting up a whole bunch of Talos VMs onside this node, having them log into our Omni instance, and then seeing if we can create multiple. We can slice those up into however many clusters we like. Add those VMs to this cluster, so we have sort of like the workers on the same of the cluster inside the cluster. Yeah, it'd be a bit weird, not exactly a production ready setup, but it could be an easy way to show just how much you can run on one of these machines.
It sounds ridiculous and fun, so I think that's the right.
Yeah, I like ridiculous and fun.
Yeah, and I'm pretty much just going to follow the instructions for the Kubernetes install, because I haven't done it in a long time. So I have no idea how that's going to turn out.
Well, I gotta burn a USB drive for my Raspberry Pi and transfer my ISO. So if you want to show that while I'm doing those other two things, that would be fine. Unless someone else had another workload they wanted to jump into.
No, right. I think this is actually a super interesting use case for this densely packed of a machine. It's actually, I mean, some will argue the blast radius and it's scary, but I mean, there's just so much you could do with virtualization on a machine like this.
Tim, you're going to want to blow up your font a little bit for us.
Okay.
I know it's going to ruin all of the columns, and I'm sorry.
Yeah, that looks horrible.
But if people can't read it, it doesn't matter anyway. So
it's a fair point.
Yeah, to be honest, one of the workloads that we're seeing, and I'm sure you guys are seeing, is things like Atomic or Kata, gvisor, like the micro VM type hypervisor. Just adding that extra layer of isolation boundary for each container, essentially. So yeah, anything around, and then those are cool. Obviously, given the nature of this year's hot IT topics, virtualization is apparently exciting again with all the VMware news. So like you mentioned, anything around virtualization is always exciting these days, I guess.
Yeah,
absolutely.
We've seen some folks come to us wanting to go basically, doing exactly what we're doing today, which is bare metal Kubernetes, and then getting their VMs onto Kubernetes with KubeVirt or something like that, right? We've certainly seen that a few times now. So.
It's funny coming from the, and I grew up early in some of that enterprise virtualization days, but mostly have spent it in open source cloud. But seeing the end user experience going from, like a point and click VMware infrastructure to, hey, you got to go get ops driven essentially with, trying to do more complex scenario and management of virtualization on Kubernetes. And I think, that's going to be one of the, I think, challenges that folks are going to find when they, if they're new to that model and adopting it, right? But obviously, from a cloud native workload perspective, if you're already doing it for your application infrastructure, it'll be the same. But straight up VMware, it's not your point and click, experience. I guess like a lot of the UIs are moving to a Kubernetes back solution, right? A lot of YAML.
This may be a silly question, but I know with x86 you can emulate ARM and you could do VMs. Is it possible in reverse? And what's the performance?
Absolutely. And in fact, I try to convince folks, like, especially if you're building binaries today for multi-platform, you can literally reduce the cost of everything by just moving to ARM and then cross-compiling your binaries on for Intel on ARM. In some cases, certain workloads, it's almost like 18% the cost, right?
Wow.
So when you think about that, that's significant. And when days where everything's about especially on the cloud, a lot of concern. Number one concern for everybody is the spend, right? That's a really kind of low-hanging fruit from one thing you could do to help reduce that is change architecture. But yeah, absolutely. I suggest it all the time. I'm still trying to get someone to pull it off. But yeah, most of what we see or what I see, because I do a lot of work within the open source system, a lot of different, Linux operating systems and such. And, today it's all, native on native, right?
Yeah.
Or at least trying to at least a lot of what I've tried to do over the last 5 years is ensure that that's the case rather than cross-compiling, ARM on Intel.
Yeah. Cross-compiling isn't fun.
But like I said, from that's the other thing people don't realize, right? The majority of endpoint devices today are ARM based, right? Because your primary computing device is your mobile or your tablet versus PC, like it used to be, right? Like in terms of how we're interacting, with the infrastructure that's out there, literally like in the application infrastructure. So. From a workflow perspective, right? Like it makes more sense. And, if you see the push with Apple and then, now the M4, right? Like, and
the Snapdragon
and announcement with, I think it's Snapdragon X, right? And their platform, you're seeing that, hey, like momentum behind, ARM native development at the lowest level, like hey, I'm a developer at my basement or at the all the way through up to the servers that are running this stuff in the background. And when you think about it, it's silly to have something be not this for all like logistics and simplicity's sake, right? Like to have that Intel component in between doesn't really always necessarily make sense. So it's like, you could have from my perspective, have some, I guess simplification on top of that, cost savings, depending upon the application stack, right?
Sorry, quick question. Purpose of installing Kubernetes.
Yeah, someone want to take that one?
I mean, really, because like we said at the beginning, it sounds ridiculous and fun. I mean, at least for the purposes of this stream. But if you're asking what the purpose is in general, one common thing that I hear is that we're a legacy shop. Tim, do you mind muting real quick?
I apologize.
No worries. One common thing that I hear is we're a shop. We're starting to become cloud native and we're almost there, but there's this Windows application that we can never get rid of. and it will stay around forever. And so they're looking at, like, literally for just that single application, they'll install KubeVirt so that they can get all the benefits of Kubernetes, and then they'll install the Windows machine. One of the reasons we're looking at it is to potentially start offering some managed control planes. We're just experimenting with it. I don't know if I should be saying this out loud, but I'm going to give you an example. I think it's a great use case for it. It could be a great way to build sort of like multi-tenant Kubernetes clusters. So like a bare metal Kubernetes cluster that is built on top of Talos. And then on top of that, you have a KubeVirt installation. You could create tenant clusters. There's all kinds of reasons, and you're going to hear differing opinions on whether or not you should just go all in on containers. But there are some legit use cases out there. I don't know if anyone else has anything to add.
Well, I would say, the number one reason people go virtualization is isolation, right? Like today, it's the only pure way to get isolation is by virtualization. And like you said, and even look at Atomic, like we just mentioned a minute ago, like that's just virtualization without a lot of the virtual devices that, you don't need, right? So, first off and foremost is that isolation boundary. But second, why you would need it is, like you said, those legacy applications, right? Or applications that have requirements that, you can't satisfy necessarily in a container. And it allows for, it gives you a way to deploy that in a very cloud native way, right? Like, I tend to think of it, it's kind of just taking libvirt and, running it containerized on top of your Kubernetes clusters.
Yeah, I think Justin has what did he say? Something like Go is the new cloud native bash script or something. what it's so true.
I read so many Go, binaries. They're just executing out something else. And I'm like, you're just running a bash script with a strongly typed language. This is not a sorry. This is
there's unfortunately a lot of cloud native that's built on that idea, though.
I mean, like, no shade, like you should use what works, but man, let's not call it what it's not.
Well, at the end of the day, that just sounds like encapsulation, right? Like, and we've been doing it rapid, right?
It's a wrapper, yeah. Oh, wrappers on wrappers. That is my career, is like, hey, I want a better UX on top of this command. All right, here's a wrapper, right? Like, I'm gonna put this bash script, it's gonna go in your directory in your path. Okay, so I'm gonna steal the screen for just 1 second because I booted these two machines behind me. It's a laptop and a Raspberry Pi. So now we have a mixed architecture environment. So we have this AMD 64 machine, and then another this puny little Raspberry Pi, which isn't even detecting memory yet. So I don't even know. I think it's a 8 gig, right? This is a Pi 4. So you gave me this one.
Is that mine? Is that the one? Oh yeah, it's the one I gave. Yes, the Pi 4.
So that's a Pi 4.
Oh,
so
yeah,
we're good.
You have a Mount. It looks like you have a Mount Snow. So yeah, you definitely have a Mount Snow. So that's that's essentially very similar to the Mount Jade platform, but a single prop versus dual, where the Jade would have dual sockets. Yeah. Cool. That one can run open source firmware too, so that's pretty cool. I've gotten to use a lot of those and go to OCP for demos and with an open source firmware stack on them, which is
what would you use open source firmware for? What's the use case for that?
Well, just the same reason. Think about it. The same reason you would use open source software, right? Control. From my perspective, like when you get to a certain level of size, right? Like, let's be real. I've seen firmware affect software lots of times. Like, I remember a period from I think 2010 to 2017 where I could tell when a firmware update was needed on my hardware by how my Ubuntu would behave. So you know what I mean? Like, the reality of it is, it gives, when you get to a certain size, especially when you get to like hyperscaler size, where they essentially, build their own computers, you also want control of the firmware stack. Now, to put things in perspective too, if you're a larger shop or you maintain that stuff, it also, today in the age of software supply chain and SBOMs and all that stuff, it allows you to have full control of your own internal software supply chain as well. So you can roll that, sign it yourself, and do that sort of stuff. And to put things in perspective, like the HP RL300, which is the first Ampere platform that HP ships, was pretty much the first enterprise server that you could get from the vendor with open source firmware if you ask for it. So they will give you an ILO with OpenBMC on it if you want it, versus the ILO software, and release the certificates to allow you to have it on there.
That could be cool.
And maintain it.
I want Talos on a BMC and using an API instead of IPMI tool. That would be cool.
Well,
it's just a little Linux machine,
Redfish, right? And then what's next, right?
Yeah, that's fair. Could run a container registry right there on that machine, right there on the BMC. I don't know, something crazy, something fun.
So I have those machines booting. Oh, I didn't export. Wrong terminal. There we go. Let's see. So I have the one there. These other two machines, I just added them in as different workers. We'll have a mixed architecture now for ARM and x86 and AMD 64. And I'm seeing what Tim's been doing. So we have a bunch of vert controllers and handlers.
Yeah, basically the installation of the operator, all the CRDs, and a control plane for kubevert. I did notice from the sort of the example that they gave on their website, they support no cloud. So I actually just generated a no cloud version of Talos for ARM64, downloaded that. Well, I didn't generate it, I downloaded it directly from Omni. So now I'm going to put that up somewhere and figure out where I can put it up first, and then boot that machine.
Yeah, I guess you can't pixie boot a pod.
Well,
I don't know. Yeah, how would you pixie boot a VM inside of KubeVirt?
I bet you there's a way. Should we be doing it?
Figure that
out.
There are options to supply TFTP boots.
That's actually easy. That's actually easy. Kimo supports direct loading of the bootable into the memory of the VM. That's what we're doing all the time. So we can basically directly load Linux kernel into RMFS into the VM memory on the first boot.
But where do you store that initially?
Well, I mean, it doesn't matter because Kimo starts on the host, right? Well, in terms of KubeVirt, it will start in Kubernetes, right? So whenever it just starts Kimo, it passes them as args. And here's your initial kernel. I mean, you don't need technically to do real pixie booting with Kimo. You can do that as well, but just probably not worth it, right?
It just has the capability of loading the init RMFS and kernel directly. If you just
So basically loads them and kind of jumps the CPU into the kernel directly. So as if it was loaded by some bootloader or something like that.
Ritesh is asking about cheap Ampere servers that they could play around with.
Yeah, so I would say go sign up for Oracle Cloud's free tier, and they'll give you, I believe it's 4 Ampere cores and 24 gigs of RAM that you can carve up between 1 and 4 virtual machines. So that's probably the cheapest, I would say. If you're looking to buy a platform, I believe if you go to CDW, the ASRock Rack platform will come in a 64 core. You can get it as a kit, so you get the board, the CPU, and a passive cooler for I think it's $1,500. And then one of the other platforms that's available would be the developer kit from ASRock Rack, and that's the ASRock Rack board. It's like the chip goes on a piece of silicon, and that plugs into another board, exposing ports and interfaces and all that sort of stuff. It's a little bit different, but yeah, and it might be that one might be a little more expensive too, more like $2,500, workstation class. But yeah, I'd say if you're looking for an instance, try Oracle. If you want to build something, or try that. Look at the ASRock Rack system, which, like I said, it's a board. It would be a build your own scenario.
Aaron was asking our goals here in running Talos virtual cluster inside this cluster. Yes, that is the goal. Are we going to do it? That is That's another question. So we're trying to, but I also want to look back at this comment here about adding labels to the ISO and automatically adding the machine with that ISO to an existing cluster. And yes, this is possible. And I was going to show how to do it with machine classes real fast, but I'll have to scale down my my cluster. I got to throw those machines back into that. Pie's not ready. I was having
It's
problem
probably if it's extracting, I'm sure it
Still
takes forever.
computing.
it's probably slow. Yes.
Yeah.
So let's scale down this cluster. And this is I made a class, or I made a separate worker group with the x86 machine. So I'm just going to remove that and update, and that'll kick the laptop out. So I have it's a Carbon. It's an old Lenovo Carbon X1, which turns into a Kubernetes. Anything that has a computer processor in my house turns into a Kubernetes cluster at some point. So we can pull that out. And as you were asking, in the installation media, we can install the extensions, but we can add labels here. So I could say like new. How does that show up? New? What is that? I have to do equals, right?
It's a colon.
Colon? It's a colon, right? Yeah, there you go. Now it's bolded. Now it's parsed properly. So yeah, you would add a label here to whatever you're downloading, so that when it boots up, and that's basically adding the kernel argument to like say, hey, by the way, when you're booting up, you get this label. So that would automatically be added to the machine. I'm not going to do that because I already downloaded the stuff. But then you could set up machine classes based on those labels, or a variety of different things. So if I want to look at a machine class, I'm going to call this my x86 machine class. And I'm going to look for my Arch AMD 64. And so that's pulls in that one machine that I just kicked out of my cluster. And we're going to create a class on that. And then I go back into my cluster. And if I want to, did it remove? Yeah, it's all gone. So I say, add a new machine set. I'm going to base this on a machine class. And that's my x86 machine. I could say use all of them. Anything that boots that's x86 or has that label, the AMD 64 label, matches this machine class and then gets joined. Or I could say only add one or two or whatever. So I'm just going to say add them all. And that'll automatically pull this laptop back into the cluster based on the automatic labeling system.
That's also a way to basically that's how you basically do auto scaling within the Omni context, at least for now. It's not fully built out for more than that, but you could absolutely pre-bake in labels and then create a machine class that says, give me infinity number of workers, and they will get auto added straight away.
And because some of those labels are automatically added, things like platform metal, right? If I had a platform AWS, I could say, oh, anything that boots AWS into this accounts, add it to machine class, or at least like anything AMD 64 or this size or whatever, add this machine class to it and then automatically add it to a cluster. And then it will, with that machine class and worker group, be added to the cluster automatically for you. So yeah, that is basically the auto scaling group. And I get that machine class label here, which everything's smushed because I'm zoomed in. Oh, and it's already running.
Yeah, and you can also do stuff like instance size. You can have a more specific label selector saying that should be more than 4 cores, but less than 16. Yeah. So like all machines within that size will.
And it is on my to-do list, literally right here, of showing examples of doing that from an on-prem cluster to bursting with Carpenter into AWS. So we're getting there. I got a backlog. All right. Is Omni self-hosted? Yeah.
I was just going to say, he was asking about that. And the answer is it can be. Yeah. We do have the Omni SaaS that we run. And then if you go to github.com/SideroLabs/Omni, you can also download Omni and run it yourself. It is business source licensed?
BSL,
right?
Yep.
Yeah. So that means that basically for anything that's like test or dev, you're free to run it yourself for free. And it's not until you go into a production context that you would need to buy a license for that.
I would just like to point out that on-prem is fine. Self-hosted is probably really risky. Like having your Kubernetes cluster managed by the Omni within Kubernetes.
No, yeah, maybe
that's not a good idea. I don't know. I mean, it depends on on-prem, like you can host it yourself, Omni, not a problem, as Spencer just said, but having Omni manage the cluster in which Omni is deployed is probably not a good idea.
Do you want to run it yourself, or do you want turtles all the way down? That is a different question.
I suspect
We
I haven't
tried
tried
that.
it, but I suspect it's doable. I think you could probably have an Omni cluster run Omni.
Until it breaks.
But if there's any team on this earth that has tried this, like, self-hosted thing, and we've tried it in every form. We had BootKube as part of Andre's gonna, he loved when we were running that. That was fun. He's gonna exit this live stream. We were running BootKube. We were, cluster API, self-managed. None of it actually works out well, in my opinion.
There are some things you just want to keep separate. And it's like, make that a separate problem and don't.
Yes. It's appealing at first. I totally get the appeal to it, but it's just in practice, man, it's just not worth it.
All right. And my Raspberry Pi, these things are just so slow. It's like when I'm looking at the Ampere stuff like that, how fast did that come up? And I've been playing with the Pis for over and over again. All last week I made a video and I was just like, oh yeah, I forgot these are slow.
Yeah, no, it's
Especially for
funny.
control
Like
plane.
people who have only experienced ARM-based compute through Raspberry Pis when they move to Ampere platforms are like blown away. Yeah, it's a completely different experience. Yeah.
Yeah.
Do you guys have to
real cores and lots of them does for you, right?
Just a little bit of power, right? Like it's like, hey, guess what? If you like plug it into a wall and don't just suck 5 volts, like it turns out you can do some computing.
Well, the thing is, right, like comparatively to like the class. So if you look at like the comparative class of Intel Xeon that we're going after, which is the top of the line, that uses like 500 watts of electricity versus the Ampere Ultra family, which each of the processors in that range use 250 watts. You know what I mean? So that's half. And that's, and you think about that from how much less heat, we go back to that whole, the cost savings, comes from a whole lot of areas, not just the overall cost of the platform. When you go to actually operate it, you're generating so much less heat that, it doesn't require the same amount to cool. And, it's
I've been trying to find a good benchmark for compute per watt, right? Because that's like the ultimate, like, hey, how much work can we actually get done for this amount of power to come in? And that's like, if people want to be green in their data centers, like if you lower that, like increase your compute per watts, a lot of things you get more benefit from.
So we call it price per performance per watt, right?
Price
and then if you look, like Kepler is the only project I know that is like trying to expose at least some of the underlying, guts from a Kubernetes and so that kind of CNCF landscape perspective of some of that kind of metrics we would need to be able to start getting real deep into understanding some of that from a Kubernetes perspective. But yeah, no, it's true. Like that's the key, right? Like when you think about how much, like just silly stats, like 70% of I think Ireland's power goes to like Microsoft, Google, Facebook, and Amazon, right? Like like there's mandates. I know there are in like legislation at the policy level, within governments, both I know, and there's some in California. Especially there's also others because of the stuff going on in Ireland, like throughout the EU, where they're limiting the amount of data center space being constructed, right? Because you're pulling electricity from the people living in those areas. So like it's a necessary thing to think about. And what people don't realize, everybody's talking about AI right now, and that's the big buzzword. But the reality of it, if you really think about it, if you listen to Intel, NVIDIA, and AMD, like the first thing they'll tell you is we need to move to liquid cooling as soon as possible. And and don't get me wrong, for some of those workloads, if you're going to be doing GPU training, you might you're going to need some probably some liquid cooling rigs, and I'm talking full immersion. But in terms of like actually running that from an inference perspective, no, you don't necessarily need to have GPUs to do that. In fact, those types of workloads run, just perfect on an Ampere type platform. And once again, when we were talking about like 18% of the cost savings, like when you think of those GPUs can be up to like $40,000 a piece up, right? There might be 8 of them in the server, and then one of those in a rack or the room, depending upon the size of the,
All I know is the secondhand server market on eBay in 5 years is going to be lit. I am ready for that.
Well, it's funny you say that, because anybody buying GPUs today, they sit there going like, okay, I'm going to have to, like, if I'm on a 5-year budget cycle, that doesn't work with the rate at which you need to upgrade your GPUs. You know what I mean? Like,
no, there's going to be so much secondhand amazing compute, especially on the GPU side in the coming years, that I'm just waiting for it. I want to show off. I want to show off this the workload selector that we were talking about, as far as like separating out x86 ARM. So I have a standard Nginx deployment, and in this case, I'm saying like just run it anywhere. Just run it anywhere in my cluster, and in whatever node is available, that's where we want it to go. So we're going to apply that, and I'm sure. Oh, no, it worked. Okay, get pods. I think it all went default, right? Yeah, okay. So we're creating a container. If I look at wide, because I know this was, again, one of those questions, and it looks like there's, 1, 2, 3, 4, 5 ended up on the Ampere hardware, and 5 ended up on my laptop. And that makes sense. The Kubernetes scheduler wants it to be highly available by default. It's going to split the load and just say like, hey, we're going to spread this out because we think that's the default right thing to do, and you didn't tell us otherwise. So that's what we're going to do. But then I have the Nginx ARM, here, which all it's doing is selecting any node in the cluster that has ARM 64. And I can do this with AMD 64, ARM 64, whatever. And sure, we can run 40 of them. Why not? This is a big machine. Nginx is going to take nothing.
100 of them.
Yeah, it doesn't matter. I guess at one point we're going to hit the 110 limit of IP addresses, because we haven't changed anything in the cluster. So we'll run out of IP addresses on that. For sure, there's always some restriction. There's always some resource that we're going to hit a limit on, and usually it's IP addresses.
Yeah, that's one thing. People who usually, especially folks building operating systems that I've seen, they tend to have to increase their core count once they come into into an Ampere platform in the mix. So,
what I failed the image pull. Hold on, I have something wrong there. Oh, maybe this one is not
multi-arch.
Yeah, maybe. So let's pull from the Docker. Although those are all mirrored from Docker library, so I would think it would be. Let's try that again. Creating. There we go. So if I go wide, we'll get a bunch of those. Let's go real small here so we can see them all. There you go. So all these machines here, all these Linux or Nginx ARMs are targeted for that architecture. So again, and you can target these things with any amount of labels. So if you have different labels on your nodes, if you say, oh, I only want these to run on Ampere because of better performance, if you only want something on the Pi, that is an often question that people look at. As soon as they're like, I'm multi-arch, like, okay, wait, are you building multi-arch images now? And some people don't even know like that's possible, right? Like Docker, like registries allow you to do that, and the runtime figures it out. So those are all portions of getting prepared to run in a multi-arch environment.
Yeah, it's not always 100%, but because there are a lot of those case, like I would say edge end cases, right? Last mile cases that might not have ARM stuff fully enabled. But when you think about it, all the major Linux distributions all ship and package for ARM today. So it means that the container images and a lot of that stuff are usually at the arch. And you guys are firing up an Nginx workload here. Like inside of Ampere, we've actually done a ton of work like benchmarking Nginx on Ampere platforms. It's we're talking about price per performance per watt. It's one of the core workloads we can come in and scientifically show that it's a lot it's as performant and a hell of a lot cheaper to run, caching and those sorts of things on an Ampere platform.
Yeah, speaking of multi-arch, it looks like a somewhat critical component of KubeVirt that would allow me to upload the Talos image into the cluster for KubeVirt to consume is x86 only.
Which component is that?
It's called the CDI, the Containerized Data Importer.
Well, now we have an x86 box in the cluster.
Yeah, you might have to pull a new. From my understanding, is KubeVirt does fully support ARM. You might have to pull a new version, is what I'm thinking.
I'm using the latest version, but this might
maybe
be. It might well be the manifest that they publish on the release don't have the ARM version, and you actually have to use, rather than using a multi-arch image, they maybe separate their images into different arches. So I'm just going to try and dig that out if I can.
So we do have an x86 box in here, just if it should be able to run just for that, right?
Yeah, but then well, that's the thing. Now I have to target if I want to run it on that, which actually
does the data importer go on locally on the node that it runs on? Is that the?
Yes, you have to expose it with a basically it's like a proxy. So I would upload to this data importer.
What happened to Tim's audio?
Yeah, it just went dead.
Oh, batteries. Batteries. Sometimes wires are better. Either that or the KubeVirt developers are like, no, cut his audio. We got to get him out. What I'm looking at this, what is Cerebrus? What is this? No idea how to say that. That's my best guess.
I've never heard of that either.
You got a nerd snipe a bunch of us on this live stream right now. It's gonna be fun. New compute. All right, something else. Hey, if you know someone over there, send them our way so we can do a live stream getting Talos right on their hardware.
Wait, over where?
This Cerebrus. It's like new hardware for AI, machine learning stuff. Or is it just Gen AI? I don't know. Leading ML. For anyone that's outside of technology, I wonder what these acronyms appear to them as like.
So it's funny you say that, because over the course of the last year, I've been trying to do a lot of research into when we talk about AI and ML infrastructure. What is it? Like, what are we talking about? Like, I grew up in OpenStack, right? Like, I can sit there and tell you every Lego in the, in the mix. But when we talk about AI and ML, what are the Legos, right? What color bricks do I need to build this infrastructure? And the reality of it is nobody can really tell you anything, because it's essentially, the way that I look at it, and I've digested it now, right? It's kind of like HPC, right? Like the old school days of high performance computing, where essentially the way someone starts out today would be like running models in like Jupyter Notebook, and then evolving, up, and so it's a scale up. So you would add GPUs to this first node, right? Because once you have to network across those GPUs, it gets wicked expensive. So you know what I mean? Like, so by the time you get to that level where you're networking across GPUs, you typically have the level of sophistication where you build your infrastructure yourself, kind of custom, out of like into an API, right, with a scheduler, much like you would schedule workloads across stuff in an HPC world. So I think right now, like a lot of and when people think ML ops, like, we're talking about not really anything to do with what that AI ML workload is, but more all this stuff, watching it, right? Like, and reporting or surrounding it or encapsulating it, right? Like for observability or security or whatever, right? So it's and even that is, can be it's a lot of it's just the standard stuff, the same as you would have for regular servers. So I think a lot of it, when you look at what cloud providers are offering, essentially it ranges from, I would say infrastructure with Kubernetes and GPUs to PaaS layers that have, curated libraries and stuff. And then users fall into some category in between. From my understanding is it seems to be, once you get into it, it's a lot more custom, and you develop that sophistication, but I think it's still Wild West.
I mean, I just love that you called out that HPC is like an old school, but really it's the new school now, right? Like it's come all the way back around, and it's like, oh, you know what we want to do now? Everyone wants HPC environments. They just want to call it. They want to call it something else.
we were just talking about virtualization being popular again too. It's like there's lots of things that are kind of like we're realizing it's like, oh, these workloads are extremely similar. You know what I mean? Like the use case is similar. The model of how we run it and operate it is similar. So and when you think about it too, like you are, batch processing lots of stuff across lots of things that can compute. So it especially in all cases on the learning side and on the on the inference side too. So it becomes a I don't know. A lot of things are all from my perspective, everything's a pattern at some point in time, in technology.
It all comes back around for sure. And it's all different acronyms with different titles, and people think they invented it for the first time. It's like, actually, I think I know this.
Throw an ear and eye in front of the whatever it is, and then it's reinvented.
Yeah. Yeah, I feel like some of the smartest people in technology that I know, or at least I've worked with, are the ones that remember what it was like 10 plus years ago. And there's like, it's like, right, if you can go back at least 10 years and you're just like, I can remember what we did before, and I can remember all the gotchas, and I can look ahead to how this is going to affect us in the next 5, right? And it's just like, oh, if you can just keep that buffer of like a 10 to 15 year mark of like, hey, we've done this before. We call this something different.
It's funny you say that. I find myself, I love like the history of the industry, right? Like, and I've been working in open source over like, over 25 years at this point. So like, and I was racking servers back in the 90s when, like your rails would come in parts with screws, and you'd rack the whole thing. You'd go to put the you'd get like halfway through and you'd realize you had one U that was like off a little bit, or wasn't long enough, and you'd have to pull the whole thing out and start over, right? Like just seeing, from my perspective, just like looking at that sort of stuff, it's crazy the level it's come. Having been around through, I spent a significant portion of my career working on hypervisor technology in the early days, seeing, the evolution of that through to, from that as a standalone technology to that as managed with cloud infrastructure and APIs to containers and the, evolution. And now I feel like, with this, where like KubeVirt as an example is another reimagination of private cloud, in my perspective, with a cloud native user interface, right? So it's a lot of times we end up recycling a lot of the same stuff, over and over again. So it just happens.
I have a podcast called Ship It, and we talk about infrastructure and how things run. And but we recently started doing what we call retro or historical interviews with people that used to run infrastructure from the 90s and 2000s. And so we had someone come on and talk about WebMD. He was responsible for deploying like the WebMD sites 20 plus years ago, and it was just like, how did that work? He's like, oh, SSH in, and we pulled down the files. And someone else ran AOL chat rooms. And like her job was like, yeah, I was responsible for the infrastructure behind AOL chat. Like, this is so fascinating because it's like something that not a lot of people get a glimpse into because it's not talked about anymore. It's not the Medium blog post or the Hacker News top of the page or sort of thing. It's like, oh, but this is how it used to work. And guess what? Like you need a lot less overhead than you think, and people are overly complicating some things.
So I don't want to get into, we'll save this discussion for that chat, but I ran the largest continuous integration infrastructure in OpenStack at the period of time when that was the big project. So yeah, I could easily.
Well, then you need to email me, and we're going to talk about
have a lot to say about this experience, because like when we talk about, and like one of the things that drew me to your product suite, right? Like I've been having worked in virtualization and that idea of floating, you know what I mean? Like you're floating on your infrastructure, right? Like, and being able to, and I grew up in the whole pets and cattle time frame, right? Like if you know that terminology.
Yep.
But if you have this, like your management plane, and you can think about it, being able to replace all your hardware over time while maintaining the entire state of everything above it, right? Like, and being able to do that as frictionless, having automated quite a bit of, let's say, entire life cycle from Pixie through to, full application deployment using a lot of the older technologies back in the day. Like, that's excruciating, right? Like seeing how far it's come with a platform like this, where we can say, okay, just Pixie boot this kernel and look, it's in the control plane ready to be consumed. And you guys are like, oh, it's click, click, next. Yep. And now we're running all this stuff and doing it in a way, when you think about it from a, such small footprint, right? Like immutable image, like when you think about operations side of it and what it takes, right? Like software is a moving target, right? Smallest, the smaller, the better. When you think of running on a lot of machines, even more important to maintain tight control over that from a security perspective and all that. Yeah. So, it was one of the things that really stood out to me when I decided to reach out to you guys to talk about, like, what can we do to show this together? Because it's it's a very compelling. I think a lot of people want, they want to see things just work and work easily. And we all know this isn't, all this stuff is extremely complicated, right? Like as someone said to me, running things in Kubernetes is like, well, specifically in the context of running OpenStack in Kubernetes, so like take this wicked complex application that's difficult to troubleshoot and run it in another really complex application that's really difficult to troubleshoot. It's like, and that's the reality of it is, right? Like, so having a simplification around a lot of the other software components and doing it in a way that's like really tight and streamlined, that you guys have obviously, shown is pretty cool. And having a single pane of glass, right? We always get that. I've heard that, throughout my entire career. Folks want a single pane of glass when looking at their infrastructure. And you guys, seem to have a really good grip on that in terms of how you present it, as we've seen, whether it be, metal instances in an Ampere lab, cloud instances, or other stuff. That's pretty neat from my perspective.
I mean, we agree. Thank you.
It is. I'm just being honest. I've always been a fan of things like CoreOS and Flatcar, Rancher OS, K3 OS, like those purpose-built, operating system.
When you get a single purpose thing, it just makes all of that other complexity kind of fade away, right? It's like, hey, I absolutely love systemd. Systemd is a great init system for a general purpose Linux distro. I use it on all of my machines. I've been running Linux for 20 plus years, and systemd, compared to the sysv in it, I hated that, like the bash, like name a thing with like the number in front of it to like order. I'm like, what is this? Like, this is garbage. And like systemd, I was like, okay, I like everything should run in parallel. All that stuff made so much sense to me, and I really love it for general purpose stuff. And then like when I found Talos, I'm like, no, this is the thing that I want for Kubernetes. Like if all you want is Kubernetes, like this is the thing to just make all that other complexity go away. You have to simplify all those options into one thing.
Yeah. And it's funny too, because you made so my perspective on all this stuff, right? Like containerization is really the revolutionization of software packaging at the end of the day, right? Like you can deliver full applications with all their dependencies, and operating systems become libraries. So it becomes, it changes the dynamic of that. And when it does that, right, it allows for, you don't need the complexity of that underneath, right? You just need to get to Kubernetes kind of as fast as possible, right?
Like the Kubernetes API. And that's what
get me to the management plane as fast as possible. And then I just need, and make sure that those APIs for pushing and, like pulling those container, like the package is there. Yeah. And that's it, right? Like it simplifies that level from an operational perspective. And I think that was one of the, that's one of the big game changers at some level. It does condense that. However, right, the complexity then is shifted from my perspective to now you're dealing with a lot of
I mean, you know the CPU, right? Like there's so much complexity in a CPU that I don't have to deal with, right? Like that's complexity that exists. It is absolutely there. And I just want to interface it through the Linux kernel, right? Like that's my interface to the CPU. Like I'm not writing assembly, and that's just fine. Like I enjoyed it in my grad school days, but I'm not doing it anymore. And that is just like, Tim, I don't want you to suffer through a KubeVirt install. We've been going for about an hour now. And I saw that you were mentioning that we need a bunch of other stuff. So we want to do a second live stream with this. And I think at that point we can probably do the HA Ampere machines with KubeVirt, because you're like your batteries are dying, not just your headphones.
Yeah, not just in my headset. Yeah, it requires a lot more setup than I was expecting. We need persistent volumes, obviously, to store everything. I need to create a proxy so I can upload images. Yeah, there's just a lot more tweaking needed. And I've set up a small host path volume, but I haven't just been able to fill it with the proxy with the upload yet. So
yeah, but you're reinventing VMware on top of
real time.
If I can do that in an hour, then yeah, that'd be pretty cool.
No, but in all honesty, too, I'd love to see one system's a toy. Or actually, I've worked on platforms before where people would call our stuff toys, and then you'd have to really show them what it did. But I look at it this way, the Ampere platform's on a toy, and to me, what really makes it cool is when there's more than one. So yeah, I'd love to see what my my pals in the lab have floating around, and see if we can jam exponentially more cores into the mix and have a real experience. And maybe we can try this again in a couple of weeks.
Yeah.
And get
and
those
even showing, if we have 3 to 5 systems, we can show more realistically what you would want to do if you have this in your data center, because you don't want to self-host this. This isn't actually like what we're deploying right now. Isn't like, oh yeah, just throw it in the same cluster and have more VMs inside it. Like you probably don't want to do that. You probably want to have a control plane externally from this that's like, hey, we're gonna go ahead and manage Kubernetes cluster or Omni or whatever we want to do from a single box, and then we have everything else is running in the workload cluster or with VMs and carving that up multiple times. So yeah, I think we could show that at another time, which we have to figure out all the components. I did want to talk about this question here, Ritesh, about the GPU pass-through. So one thing that's funny, like when you're on bare metal, there's no such thing as pass-through. Like it's just like it's part of plugged in, like it's natively there. I don't know how KubeVirt does GPU pass-through. I think it does support it because I know the underlying virtualization layer does. But yeah,
I would imagine it's all in that YAML configuration and how you define the virtual instance, right?
Yeah.
Like it's having done it in regular libvirt for years now, both just any device pass through, it's we know it exists. I would imagine it's just properly configuring it.
Yeah. Yeah, as long as the feature's exposed inside of some KubeVirt API, then I'm sure we can do it. And to the Talos side of it, we do have support for that through extensions. If you go, I think I made a YouTube video about. No, it's not. That's my next YouTube video. We have a video coming out on just like at least getting an NVIDIA GPU, but you do it through extensions. So we have like if you want AMD, if you have an AMD GPU, you can get that for NVIDIA. You would get stuff like the container toolkit, which configures containerd, and then the proprietary, the non-free NVIDIA KMod driver. And so you could get those as extensions, and then you would download your installation media, however it is that you're installing that in AWS on small machines. I have a machine right here, literally above my head, that has a GPU in it, which is what I'm doing the video on. So we'll have that in the future for showing off how to support that stuff. The extensions also work for other drivers. Like this laptop that's booted, the Lenovo, doesn't have a NIC integrated in it. So I actually have the modem driver. The USB modem driver allows my USB-C network card to work. Otherwise it doesn't work. So I have to have a extension for that. So if I even go, let me show you, because this is a fairly new feature with showing the extensions here. You can see I have the extension installed on that machine inside the cluster, and you can add and remove extensions from here after they're added to the cluster. So I can say like, oh, I want Thunderbolt drivers or whatever. If you want gvisor installed, you can get those things with basically a click, and it does a reinstall or a pulls down the new extensions and installs it for you. It's very slick. So I'm going to go ahead and pull my screen out because, yeah, we've been going for an hour and 10 minutes. And Peter, I thank you so much for joining us and talking through everything and also giving us access to the lab. As soon as we have a few more machines and we can play around with KubeVirt a little more, we'll try another live stream and do some more, maybe some, VMs with Talos inside those VMs, running more clusters and show you how to run multiple. This is a single cluster, right? We have a single node, single cluster. How do we run it across multiple machines? If we have 128 cores in each box or 256 cores in each box, like you can run a lot and you can do a lot with not that much, especially comparing, again, like the price point of the Ampere hardware is amazing. When I look at like, what does 128 cores cost me in Amazon? I'm like, oh, wait a minute. I don't even want to go down that route. You're muted. Peter, you're muted. I can't unmute.
No, I got it. Yeah, sorry about that. Yeah, I was going to say, especially as long as those aren't graviton cores, because you'd probably find a similar, maybe experience because they're also ARM based. Yep. So, but yeah, from that perspective, it's all from a server-based computing. All the ARM ecosystem is in the same position right now of trying to convince the rest of the industry that, hey, you need to move to ARM, and this is why, right? So it's not just Ampere, and as I was saying before, we know we're going to be for the foreseeable future in a mixed environment, right? Like we just want to show people that, hey, there's a really compelling reason why we can save, you can save a lot of money by moving that architecture, especially for any workload that can, right?
Yeah,
like should so.
So thanks everyone for joining and watching the stream, and we'll have another one scheduled whenever this is going, and we'll talk to you all soon.
Thanks, guys.
Thank you.
See you guys.